For the section, so very similar to the last one that we did in defining a locus, and so I'll do this one as quickly as I can. We're going to let z equal x plus iy, which is the usual substitution that we make when we're doing graphs, and I'm actually going to get right into it. So that the modulus of z minus 2, I'm going to substitute in x plus iy, and I'm going to be using, make sure that you've watched example 27 before this, because I'm shortcutting everything here, because I'm assuming you've seen that one, which is going to be the real parts squared, excuse me, shortcutting it so much I forgot the 2. The real parts squared, so x minus 2 squared, and the imaginary parts squared. Okay. The other modulus that you have here is this one, and making a similar substitution in there. The real part is x plus 2 this time, so I'm going to square the x plus 2, and the imaginary part is the y squared. So now what we have, if we put all this together, the mod z minus 2 minus mod z plus 2 equals 3 goes to this expression, which is x minus 2 all squared plus y squared minus x plus 2 squared plus y squared, which equals 3. Now this is fairly ugly the way that it is here. So what we're going to do is I'm actually going to move this square root over to the other side. Okay, so and I might actually get rid of this so we can expand it nicely over to here. Right, so going to move that over. What that's going to do for me is make it easier for me to square everything. I'm going to square everything because I want to get rid of the square roots. That's what we have. What we're going to do now is square both sides. And squaring both sides, the square root will disappear on the left side. On the right side, it's not quite so nice. So on the right side, what you'll actually end up with is 2 of these brackets that contain this horrendous mess. Okay, it's going to get rid of a bit of the square root, but we're also going to end up with it appearing again. So we've got x, I'm actually going to expand this x minus 2 while I'm expanding. So the x minus 2 all squared would be x squared minus 4x plus 4 plus y squared. Here, the 2 square roots together will cancel out the square roots. So that's nice. Here we get 3 of these square roots. We'll get another 3 of the square roots, so altogether we've got 6 of them. So that's annoying, because it didn't go away. And we'll get 9 with the 2 3's together. Okay, a bit more expanding. So we've got this, just expanding this other side as well, x squared plus 4x plus 4 plus y squared plus all of this, x plus 2 squared plus y squared, and that plus 9. We can actually see that if you've got the same thing on both sides of the equations here, it will cancel. X squared is the same on both sides, the y squared is the same, and the 4 is the same. Okay, so that's going to help us with a little bit of the cancelling. So let's pick up all of this. I'll put this on the next page so we can see. Okay, so we've got here, I've got left over. Okay, I've got negative 4x. I'm going to actually take all of this over to this side. So I've got 8x, so just taking that over, plus 9, plus 6 square root of x plus 2 squared plus y squared equals 0. Okay, now at this stage, this is where you're going to have to do some clever working. Okay, now the clever working that we're looking at here is again taking that square root, which is just awful, minus 6, and we're actually going to square everything again. Square both sides again. So we can finally get rid of that square root. So 8x plus 9 all squared. This squared is going to give us 36. Squaring the square root will then give us the square root itself. Gets rid of the square root. And I just use square brackets. Let's expand everything. So the key thing with specialist maths is the algebra. There's so much algebra, 9/8 is 72, that you need to be able to do. 9/9s are 81. And just keeping track of all the working, that's the really key thing. X squared plus 4x plus 4 plus y squared. So I'm going to put everything now over to the left side. So we've got, we're actually nearly there. May not seem like it, because we've been doing this for a long time now. 72 and 72 is 144 plus 81. And here I'm just expanding this bracket and I'm taking it all to the left side. So we're going to have minus 36x squared minus 36 times 4 as well, times 4, 4x minus 36 times 4 minus 36 y squared. Okay, like that. So I've put everything over that side, and what you'll find actually is that 36 times 4 you'll end up, we should use the calculator, 36, oh, 144, awesome. So this is 144 here, beautiful, and this is 144, and the nice thing here is that you can have a bit of cancelling, because you've got here 144x and 144x there, so they cancel. We've still got the x squared there, and we've got the y squared, and all of this is equal to 0 because I've taken everything to the left hand side. So let's simplify. 64 minus 36, you should get 28. 28x squared, we've done those two. 36 y squared, and you've got 81 as well. 81, and it's 81 take away 144. So let's check that out. Negative 63. Yep. Okay, so we've got negative 63. And just so you can see the real parts there, these parts, the real parts, that's negative 63. That all equals 0. We've now got 28x squared plus 36y squared equals 63. I'm just taking it to that side. I'm trying to get this into like an ellipse sort of form if I can. Oh, the thing to be careful of here is signs. Hopefully you picked up that I made a mistake there, which was the sign here on the y should be a negative. So let's look at finalizing this now. What I want to do is I'm going to divide both sides here by the same thing. So I'm going to divide 28x squared and 36y squared. I'm going to actually divide by 28 times 36. And the reason for that is I can get rid of the top line number or coefficient. So that will cancel, and 28 times 36, so 63 over 28 times 36, 1 over 16. So I can put that in. So I'm going to, I'll do this in light blue. So I've now got x squared over 36 minus y squared over 28 equals 1 over 16. And hopefully that looks a little bit familiar to you as a graph. In fact, what this graph is it's a hyperbola because it has the negative sign in the middle. And the way that we could write this out so that you can see it as well, I'm just going to times everything by 4 because 4 will help us to cancel this down a little bit. So x squared if I multiply both sides by 4, this will be a 9 underneath. Underneath there you're going to have a 7, 7 4s are 28, and this would be 1/4. So our final answer here is going to be a hyperbola, and I'll just put this onto the next page for you so you can see. And in terms of what this locus is, you want to give a little bit of information about it. So remember that you've got the asymptotes for this. So asymptotes are when x squared on 9 minus y squared on 7, okay, is equal to each other. So when these two things are actually equal to each other. And you'll find there that if you do your workings, so it's a lot of revision here. You've got that, so therefore y equals plus or minus square root of 7x over 9 are the two asymptotes. Okay, and we're looking at no translations here as well, so the centre of this hyperbola would actually be at the centre of our origin. So after all of that work, going back to the question that we started with, it was this question here: find the locus defined by the following. Okay, so the key thing there is that it's a locus that's defined as a hyperbola after making our substitution, z equals x plus iy. A lot of algebra, a very hard question. There's a lot of algebra in there. Okay, to get to this point here, and to give your asymptotes as well for your hyperbola as plus or minus the square root of 7x on 9. One quick thing that is stated in the textbook with this question is also looking back at some of the working that we did. This particular step here actually tells us some information about x, because we know that this square root, this part here, has to be bigger than or equal to 0, that square root part. Okay, so it has to be 0 or some positive real number. It can't be negative because we aren't dealing with any complex numbers in here. These are the coefficients of a complex number. That tells you that 8x plus 9 has to be less than or equal to 0 because of the negative sign here. So the expression that they get, and it's a domain restriction for your final answer, is that 8x, so this expression here, 8x plus 9 has to be less than or equal to 0, which implies that 8x is less than or equal to negative 9, and so 8x is, so that x is less than or equal to negative 9 over 8. So that's a domain restriction on this hyperbola. So still the same hyperbola, it doesn't change that answer. It doesn't change the asymptotes as well for your answer. So we've got those asymptotes at plus or minus root 7x on 9. And it just changes the section of the graph that you'd be looking at sketching and keeping in your graph. So because of that domain restriction there, that's an important final part of that very long question on defining the locus for a given complex equation.